Hello everyone and welcome back to this lesson on DeepSpeed. In today's lesson, we will take a look at how you can do multi-GPU training by actually sharding the optimizer and the gradients across multiple GPUs. Also, sometimes you can do sharding for the model itself. And here we're talking about the different algorithms, namely 0.1, 0.2, and 0.3. In today's video, we will take a look at how we can actually implement them using the DeepSpeed package. Today, we will be fine-tuning a 3B Llama model, fully tuning it without using any parameter efficient tuning methods. We will do this using DeepSpeed. If you want to look at the configurations, we have two configurations that we have to look at here. So if you go into the DeepSpeed directory, you will see you have 0.2 and 0.3. So 0.2 and 0.3 are two different variations of the ZeRO algorithm. The idea is that you want to shard some things that require memory across multiple GPUs. Now, there are three things that you can shard across GPUs. These are the optimizer, which is basically the thing that takes the most memory from the GPU. Also the gradients and the model weights themselves. So we've talked about the ZeRO variants in the previous lesson. So 0.2 shards both the optimizer and the gradients across multiple GPUs. And 0.3 is basically optimizer, gradients, and the model weights themselves. So if your model does not fit on a single GPU, you have to use 0.3. There is no other way you can do it. Okay, if you look at the configuration, this is what you need for DeepSpeed to work. You can take a look at the documentation. You can add actually more things than what we have here. But basically, you can see we're using BF16. The ZeRO optimization stage is 2, which means we're using 0.2. In the other file, it's going to be 0.3. And there are other interesting things that you can check out. And DeepSpeed gives you a lot of power or control over the process. So there are a lot of things that you can do using configurations like this. And we also have another configuration for the accelerate package itself. This is defines the algorithm that we'll be using. And then if you look at this, for example, this defines again how many GPUs do we have and how many machines are we using to run the process. Is it locally or on the cloud? So this is the same configuration that we used for accelerate before. And this is the configuration of DeepSpeed itself. So we will be following the same process that we used for the previous lesson on DDP. We want to start fine-tuning the model using 0.2. We'll see if it works, and then we will also try 0.3. For this, I'm going to scroll down here. So these are the commands that I need to run. This is how I can fully fine-tune a model with 4 GPUs using 0.3. I'll copy the command, and basically it calls the accelerate and gives in the path to the configuration and the path to the training script. Now, if I go to the machine, so here I'm using an SSH connection to a runpod machine, and let's do NVIDIA SMI to check how many GPUs you have. You can see we have 2 GPUs. Now I want to run the training process, but using 0.2. So I will copy the command that I have, and I will change some things. First, I want to run 0.2. So I'm going to replace this with a 2. And let's do 2 GPUs since this is what we have. And then let's run this. Okay, the script started running and we loaded the data, but you can see we got an error as soon as the training loop started. And if you scroll down, it's going to be an out of memory error. So I wanted to show you this, that some setups, you will not be able to fine tune your model, especially that we're doing full fine tuning here. So we need a lot of memory, and we were using 0.2, which means that each GPU has to have an entire copy of the model, because again, 0.2 shards the optimizer and the gradients, but it keeps the model on each GPU. It might not be possible in some setups, so I just wanted to show you this. And now we will run the script again, but this time we will use 0.3 and see if it actually works. So again, I'm going to run the same command, but this time I'll change the path to the configuration. Instead of using 0.2, this time let's do 0.3, and let's run this. Okay, so now you can see training has actually started, and it's been like 8 minutes. I'm going to wait for this to finish. But I wanted to show you here that using 0.3 actually worked. It did not cause an OOM error, and this is because 0.3 goes beyond 0.2 by sharding the model itself on the GPUs. Now each GPU is saving some kind of memory, so the entire process fits within our setup, and now it works. Now training is done, and you can see it took like 1 hour. If you remember from the DDP lesson, this was the chart. When we used 2 GPUs, it took 19 minutes. But this time, again, we're using 2 GPUs, but this time we're doing full fine-tuning. So in the DDP lesson, we were using a QLoRA model. This time it's full fine-tuning, hence it's going to take more time. And also we're using the 0-3 algorithm, which shards the model across multiple GPUs. This has communication overhead because these GPUs has to communicate with one another. Hence, this would also increase the running time. So you can see now it's much larger. It took 1 hour. And then I also generated the predictions and evaluated my model. We can see the root scores. These scores are a little bit higher than the QLoRA model, but just by 1% or maybe even less. In this case, we can say that full fine-tuning is not going to help that much on an easy task like summarization. I think a summarization task is easier for LLMs. Maybe if we tried a bigger model, something like 70B or something, maybe you can get a little bit extra performance, like 2 or 3%. But we are very close to the performance of the fine-tuned OpenAI model. But I think it's the case that OpenAI model is very huge in parameters, and that's why it's going to be better, but only by a small margin, 2 or 3%. Maybe if I want to achieve this performance, I would try a bigger model. But also keep in mind that bigger models will have huge inference cost. Maybe you don't want to do this if you don't want to bear extra costs. Finally, let's take a look at the charts. Here are the usual charts. The loss is going down, which is nice. And if we look at the memory allocation, you'll see here we have 2 GPUs. They are almost fully utilized. So one of them is at 97, the other one is at 92. This shows you that the memory allocation is very high. That's why 0-2 did not work, because the GPUs are already fully utilized or almost fully utilized, even when you are sharding the model. So imagine you haven't done this sharding, and now each of these GPU has to hold the entire copy of the model, and hence you would get the out of memory error that we have seen. That's it for this video. We discussed how you can do multi-GPU training using DeepSpeed. And keep in mind that the more things you shard across GPUs, the more likely the training process is going to take longer. Usually DeepSpeed ZeRO is going to finish faster than 0-3 by 20 or 30%. It depends on the model size and your dataset. Just keep that in mind. We tried 0-3, which is a way to reduce the memory requirements, but it will for sure increase the running time. That's it for this video. I hope you found that useful. I'll see you in the next one.